going to have, at the end of this presentation or whatever you want to call it, I'm going to have people view some material. So we pass it out, you could view it, then we'll shift it around to each person. That's toward the end of this. It's going to involve some viewing some things that we're going to talk about. So welcome to our church. We have a quality gathering, if not a quantity gathering today. So anyway, we'll do the chalice lighting. I just need someone to actually put the light on, but here's the opening. May the light we now kindle inspire us to use our powers to heal and not to harm, to help and not to hinder, to bless and not to curse, to serve you, Spirit of freedom. Okay, some of you would like to share some things on your heart and soul this morning. Come on up, as you know the procedure, and feel free to, where's the little microphone we use? Oh, it's right there. Okay, fine. Just.
Okay, I have one. Many of you know that Bill has been waiting for years with this heart thing, this aorta, had to wait till to get a certain thing. He saw the heart surgeon this month, and he is scheduled for surgery finally on the 23rd of September. So we're going in, they're putting us in a hotel the night before, and we're staying for several days. So that's my good news.
Thank you.
I'm so glad it's a joy that Lou's up here. My name's Meg. I always like to say that. I have joy and sorrow. Sorrow that I had a brother-in-law that passed away 2 weeks ago, suddenly, and I think I shared that already. And they had a puppy, too, that unfortunately had been killed. They had just bought, that got killed by another dog. So there was 2 tragedies. But 3 days ago, they bought a new puppy. My sister bought a puppy, and it's a little beagle puppy, and her name is Ruby, and she's doing excellent. So there's a lot of sorrow going on, but she is a bright spot in our lives. Thank you.
Any?
We all got our things going on. I just wanted to kind of piggyback on what Patty said and say thanks very much to Peter and Betsy. Peter gave us all kinds of information about how to get in touch with the surgeon in Rochester that we're working with. He is the guy who fixed up Betsy in her time of crisis. His name's Peter Knight. He's a brilliant guy. We've met with him a couple of times, but the whole matter of getting in touch with him has been facilitated tremendously by the help we've gotten from the Dietitians. So I wanted to say that's a joy to me because I'm very grateful and I appreciate it. And also thanks to Joan Davis, who I got in touch with her, and she had all kinds of useful information with her nursing background regarding how these things should go. So anyway, thanks to you folks. Very grateful. Thank you.
I think, well, I speak for myself, Bill, but there are anyone who knew of your situation. We are so pleased to hear this good news. And we do belong to a very supportive church, and that is wonderful too. And I just wanted to, I'm still in a caretaking mode at 80, so I do not have very much time to contribute to the church. And I just want to, I don't think we can say thank you too much in my world. And I especially want to thank you and Teresa, who's here, and of course Erica, who do all of our Zooming and our outreach to those who can't be here. And well, we all know, of course, why our church, I mean, everything that everyone that is contributing, there are quiet contributors too. And I just want to say thank you for being on the board, if that's what you do. But I know there are so many that are contributing where I'm really not able to right now, and I really appreciate that. So I'd like to light a candle for that.
Any others would like to come up? I'm sure our hearts are clear and our souls are ready, so let's get started. The general topic today is cosmology, and the educational objective, which I'll state first, is that everyone here will feel a part of the universe rather than apart from the universe. It's, again, you will feel a part of the universe, not apart from the universe. And I'll have a second follow-up on that at the end, but let's start with a definition of what they call the cosmos, which is a fancy word you may have heard many times. And it's basically from two dictionary sources I use. It's the universe regarded as an orderly, harmonious whole. Harmony and order are present. Two, the world or universe regarded as an orderly or harmonious system, a complete, orderly, harmonious system. Another definition is cosmology, the branch of philosophy dealing with origin and general structure of the universe, especially characteristics of space, time, causality, and freedom. It's the branch of astronomy that deals with general structure and evolution of the universe. And this definition comes from the years 1650 to 60. So it's a long-term pursuit that humanity's had in this regard. Another definition for cosmology is the branch of philosophy dealing with the origin, processes, and structure of the universe. The astrophysical study of the structures and constituent dynamics of the universe, the specific theory or model of the structure and dynamics. So we have a lot of whole ideas being fused here over time. When I went to Niagara University for a year, I took a philosophy course called Cosmology Philosophy 2, and the catalog at the time described the course description is the philosophy of the material universe. It is the study of the principles and practices common to material things and includes philosophical explanations of the origin of the universe, the ultimate constitution of bodies, and their finality. So coming from a spiritually based university, this is quite neutral in terms of what they describe as the course objective. So let's start on some other ideas here. First of all, the building blocks basically of the universe are the galaxies. And these I'll define as large system of stars held together by mutual gravitation and isolated from systems by vast regions of space. So we're talking about building blocks, galaxies that are basically independent functioning on their own apart from the other ones out there. So you have this space basically separating them all out. So that's the basic building block. And the basic commodity of this galaxies are stars, of which we are firmly attached and dependent on what I call the local star we call the sun. So we're only 93 million miles away from this star, which in universal measurements is practically touching it. 93 million miles in the universe is like almost this close compared to a mile. So the distances are so vast. So we're firmly in the orbit, as we see, going around the star. And the definition of time is that it's so precisely there that we don't vary over a year in our trip around the sun. It's down to a split second, there's no difference. And this has been going on they estimate 4.6 billion years, this relationship. The fathom of time that seems way out of understanding, because our lives are rather short in regard to that. But anyway, that's our relationship to a star. Without that star, we're nothing. And without the H2O, that's the other necessity, we're nothing. So those are the two big gifts we have been whatever, bestowed, given, whatever word you want to use. Today's a good example of that because the air is very wet and moist and humid. So we have a lot of H2O, but we also have the sun brightly present. So that's that. And then another version of a galaxy is a large system of stars held together by mutual gravitation. I already read that. So, well, here's the other one. Large scale of groups of stars, gas and dust in the galaxy. 100 billion solar masses, diameter anywhere from 1,500 to 300,000 light years. That's how big these things are, a galaxy. 1,500 light years ranging up to 300,000 light years. It's this little family of everything out there. The gases, which are material that's either former dead stars make up or new living stars draw on gravity of those gases and stuff to actually form a new star. So that's another galaxy definition. And so we are in the middle of one of these galaxies. Well, not in the middle, we're actually halfway out from the center. The center is, we're halfway out from this huge cluster of stars. So the sun is sitting out there, and we call it the Milky Way, which is a term that was derived from the Latin, it's galactic, lactose course. Because they reminded them milky, the white, so it's corso-lactosis. Translated in 1500, English, the Milky Way. It says a spiral galaxy containing our solar system, seen as a luminous band across the sky, composed of innumerable stars. But the key word is innumerable because there's so many of them that they defy count. It's like taking one grain of sand on a beach and comparing it to the rest of them. So that's how many of them are in just this one galaxy. We can't count them because toward the center they cluster, and there's so many of them it forms a continuous band of light because they're so close together and massed. We're halfway out, and this is a spiral galaxy, so you can a clustered center, and then you have like a pinwheel effect going around it. It's spinning, so the whole galaxy is spinning around its center, and it's also moving in space altogether. So there's so many movements going on that it's hard to imagine that we're actually moving in space as we sit seemingly in one orbit around one star, but everything's going around the center, and it's called a spiral. We'll see pictures of other types of galaxies besides the spirals, but that's what we belong to. And the key thing is we're halfway out from the center to the fringe. And the other thing is that, let me think here. We already saw that. So looking at some of the people that have dealt with cosmology, one is famous physicist Albert Einstein, and he, despite all his scientific discoveries in physics and his theories and relativity and gravity and all these things, he said toward the end of his life when he died in May 2nd, 1955, a person named Pat Miller was writing about a title called The Death of a Genius, and he was referring to Einstein. But here's the quote Einstein said. He said, comes a point where the mind takes a leap and comes out upon a higher plane of knowledge, but can never prove how it got there. All great discoveries involve such a leap. So physics and gravity, everything we know about knowledge only takes us so far. But on the other hand, what's in the universe, things are pretty much immutable. That means everything goes according to a plan. It's going to happen that way. Physics, chemistry, biology, astronomy, geology, they can, even in our knowledge spheres, we can pretty much know what's going out there. It's particularly the chemistry of the universe. They find the same elements that we have here pretty much out there, either in our solar system here or farther out. And so it's a pretty spacey thing, no pun intended, but physics is something that is still ongoing. They still don't know the whole story of it all, but everybody's got an idea what's out there. And another non-physicist who was actually a lyricist, a composer of music, Oscar Hammerstein, wrote in his musical South Pacific, he was talking about love. He said, this can apply to the universe and what we know. He said, who can explain it? Who can tell you why? Fools give you reasons, wise ones never try. So we get to a point where it's there. I don't know how you could, we only so far. It's there, it's like, in the end, it's something beyond our still ongoing investigation, knowledge, and so on. So anyway, what we have is incredible things that we belong to. We're a part of it, not a part of it. We're sitting here right now, and we're in the midst of everything we're talking about. It's going on everywhere around us, and we're right in it, no matter what our actual location is. You can't divorce our presence from what we're just finding in these words of others and ourselves. So anyway, what we have now is I'm going to have some photos and pictures of things. The first one I'd like to show is other galaxies. I'm going to have you look around at these. These are galaxies that gave these pictures out millions of years ago because it took the light from them traveling at 182,000 miles per second. It took a long time in the past for it to cover that distance. So these pictures are actually other galaxies, but it shows what they were a long time ago because the light you see on the picture didn't get here till now, or whenever this was actually taken. But if it takes 11 minutes from the sun's light to get here at 93 million miles, the next closest star is 4.5 light years away. That's how tied we are to this one star. The next closest one, compare 4.5 years to 11 minutes. That shows you how bound to this one star we have. So that's a huge difference. And yet, that 4.5 light years is nothing compared to the rest of light traveling from all over the universe. It takes so long to get here. So you have this immense thing that we're in the middle of. But and what I'd like to do is like start, I don't know, I wish we were a little closer together, but the first side is, both sides of this show other galaxies, spiral and other types that are described. And the last one is very dramatic. This is the only galaxy at the bottom that you could see with the naked eye if the conditions were perfect. Mainly low humidity, no artificial lighting, out in the middle of nowhere. So if we could look at this to give you an idea of what we're involved with in terms of other galaxies out there. And then I'll show other pictures later of our own, where we're actually at. So you could take a look at that. The first one upper left is called a spiral. That's the kind we are here. It's called the spiral form. And it's pretty amazing. There's a side view of it too. Yeah, whatever you guys, however you want to distribute that. It shows different, both sides of the sheet are we're looking at other galaxies. And remember, this is the building blocks of the universe, and they tend to be separate from each other. And they're moving away from each other also in the universe. They can just tell by the light they give off that each galaxy is actually moving away from the other ones involved in our space and time. So that's what we have there. So remember, this light that shows up on the photograph was actually started out so long ago that's almost impossible to, average lifespan of America is 76 years, so that's like one grain of sand on a beach in terms of time. So Einstein dealt a lot with time and time, universe, and he said things like if you go to a planet at the speed of light and come back, you'll actually be younger. I don't know how that works, but he dealt with things like space and time. So it's kind of amazing, but later on we'll see that there's a spiritual and perhaps moral application of what we're talking about, which is not going to be a creed of any sort. And it's not going to reflect any one of these banners in terms of definition of what's out there. It's not going to be one version of this that these banners may present, but it's really something else because of the ability to impact on us. We are totally dependent on what we're talking about here. The sun as a building block, it's a star is luminescent. It gives off all this light and heat because it's undergoing fusion of hydrogen into helium atoms. It creates a huge amount of energy, light, and heat. Yesterday I was walking home and the sort of clouds were playing games with the sun, and it was just, whenever the sun actually shone full on, you could feel the heat just being outside. Just one cloud could reduce, and then the sun was full out, and you actually feel the extra heat. 93 million miles away. And of course, it's really something to be aware of something. Field of education is hopefully making people aware of things, but also we have an assignment later, but it's really something else. Anyway, when you're done with that, I'll introduce another thing more about our local one here. Yeah, those photos are all what they call the building blocks of the universe. They're all different types of galaxies. The key thing is each one is separate in space. And there's a lot of stuff going on about how everything got to be why it is now, but that's another whole subject, but it's there. So Remember, there's billions of stars. We have one, or I call it the local star that we belong to. But there's billions of these things out there. You can see in these photographs. And there's so many of them in one place, they shine together. And I'll talk more about the Milky Way arrangement of this in the next section. But it's so incredible that it's all here. You know, it's all there, and that one, the last one, the large one, that's the only one visible with perfect conditions in the sky. It's still only a fuzzy light at that distance. It's called M31 in astronomical designations. But okay, that's that one. Oh yeah, we have. Sorry, guys, two more to see. Remember, the minimum diameter of everything in that picture is 1,500 light years. That's the smallest one. They go up to 300,000 light years. That's from one side of the galaxy to the other. It takes 300,000 light years to cover that whole distance. That's only one galaxy. There's all the rest of them out there. So we're talking about space that's almost inconceivable to imagine with our minds. Not that we're not smart or anything, it's just that it stresses the mind to keep developing new and more ways of investigating what's around us. These sheets that I'm going to present next are from church bulletins, actually, that I saved because of the incredible photography. So it has nothing to do with who published the picture. I just used it for purposes of demonstration and observation. So it has nothing to do with who published this stuff, but it was very handy for what we're doing today. We'll talk about why the Milky Way is actually called the Milky Way, because of what you have is each galaxy has a plane where most of the stars congregate on a certain plane. If you're above or below that, that's still part of the galaxy's gravitational field. So everything that holds everything together we're talking about is gravity. That's the main tool of physics to keep all this stuff in order right down to the last second. As we mentioned earlier, I mean, it takes exactly the same amount. They estimate our galaxy to be 4.6 billion years old. That's an estimation by physicists. I don't know how exact that is, but what's been going on right today and this year has been going on for 4.6 billion years, the interrelationship between this planet and the sun. That's almost inconceivable because it's so long. And they predict that there's another 7 billion years left in the sun's life cycle. 7 billion years still to go. And again, this makes me value whatever our lifespan is, because we can't take for granted what we have. And remember, our life is dependent on the star and the H2O that goes with this planet by definition. So you take those two things together and we're alive, we're here today. Everything is dependent on what's happening with those things. By the way, H2O, the sun actually is composed mostly of hydrogen anyway, which is the most simple element. And you see the relationship between the hydrogen and the sun, and the hydrogen and what the chemical thing we call H2O, which is gas, liquid, and solid, clouds, humidity, water, and then ice or snow in 3 different states of matter. It's just temperature driven, and that's another thing about the sun. Now, another thing that's key is that it takes every point of land on this planet gets exactly the same amount of solar exposure as any other place. The key difference is the angle. So if you're at the equator, the angle over a yearly average is pretty direct. Not much difference. If you're at the poles, you're going to get, in December, you're going to get no sun, but in June, in the North Pole, you're going to get all sun. So it's actually daylight. The same amount of daylight is in the entire planet. It's the angle that makes the temperature different. So it's not a matter of who's getting more sun. So daylight is defined as the actual first glimpse of the disk of the sun on the eastern horizon, the last glimpse of the sun at the western horizon before it's gone from our view. And the only reason it's gone because we have this 24-hour spinning of the planet, which has been going on for this 4.6 billion years also. And it just keeps doing what it does because everything is so immutable. The universe is hard to understand, but it's also very direct in what it does. It doesn't really vary much. Whatever it does, it's ordered by whatever its nature is. So another thing about daylight is that, so not counting the dusk and dawn, which are considered not sun up or gone yet, every place on this planet gets, on a yearly basis, 12 hours of night and day. So half of our life is basically in the dark. Although being who we are, we do most of our activity in the daytime. So that's why we don't notice so much how dark it is over time. Like I could see out my window at night, and during all night long, all I see is a blackness out there, because that's when we're not facing the sun. And everybody's going to face the sun exactly the same amount on a yearly basis. It's exactly 12 hours. But right now we're still in this part of the location, we're getting still more light than dark. After September 20th or whatever the date is, that date, everybody on the planet's going to get 12 and 12. And then the northern hemisphere is going to go down to December 21st or whatever, and we'll be at our minimum amount. But at that time, the South Pole will be all the 24 hours of light. So you see, it's not a matter of who gets more, it's a matter of the distribution on a yearly basis because we go around the sun. The other key thing is the axis of the Earth is 23.5 degrees off straight up. That's what causes the seasons. So that's what causes us, one part of the Earth, to get more light than another part on a given date. It's where you're at. So right now we're getting more light, but we're losing about 3 minutes per day at this time of the year. Basically, in June 21st, it would get light at, say, 4:45. Now it's at least 6 a.m. before the sun actually appears. So you can see the difference. And what I'm saying is all these things are mutable. The whole universe is dependent on these physics of laws. And what humanity's trying to do is understand more and more as we move along. And that's one of the functions of education. So the next one I'll send around is about the Milky Way. All these photographs are of the Milky Way itself, our galaxy. And what happens is that you're going to see basically one very bright section. And that's the spiral nature where the stars will cluster on a plane together because of their gravity. And in the middle is where most of them are. So all these pinballing arms are going around the center, including where we're at now. So these photographs are taken of the actual plane. Say this is the plane, there's stars above it and below it, but most of them want to be on that one section. That's known as the Milky Way. That's what they call it. So what you'll see is going to bright areas, and they're obscured by dark clouds. That's the dust and gas in this galaxy that blocks out some of the light. And that's the galaxy contains a lot of junk, dust, gas, things that are not giving off light per se, but are there. And they look like they're blocking things, which they actually are, but that's exactly what they do. So there's several, about 5 or 6 pictures just to look at. You don't have to take real long, but everything you see, you're going to see a concentration of light as opposed to the material in the picture around it. And that light is the plane where most of the stars, by gravity, will assemble because they're being pulled by each other. So the more you introduce to an area, the more they want to stick together like that. So the first one is, they're all the same thing. They're all looking at that galactic plane, which is where most of the stars, that's what we call the Milky Way. And in excellent conditions, you could actually see that band across, goes all the way around the sky because it's there. It's just actually what you see is the actual concentration. That's why they call it, the galactic name itself, Milky Way. So, and they'll just send this around. Don't look at who put the thing out. That's just pictures that I wanted to use. So. As we're looking, remember, if you're really out in a great, particularly a desert area with low humidity, which makes it hard to do in this area, obviously, and there's no artificial light, you can see everything that is depicted on these photos. What we see in this area is all various stars. But because the Milky Way is so many blended, it's a faint light, but it's very powerful under the right conditions. And we're in the middle of, what we see on this set of photos, we're in the middle of this. We're not, the first set pictures I sent around were out there, other galaxies. This is the one we're actually sitting in right now. That's the key thing to these photographs now, is that we're actually in this space. So stars are so important because what they do is they undergo nuclear fusion. They give all this heat and light off in the process. And it seems that life is dependent on, as we know it, and we wonder if there's other areas in the universe where it's different from our life definition or separate, or if there's other things out there. We don't know because we haven't gotten this further out there to see what's there, but physicists and astronomers are still working on these things, and they try to give answers to what's out there. But basically, if you took chemistry, remember that periodic chart of the elements? It showed all the elements with their atomic weight number, and the only difference was in an element is how many electrons and protons are present in it. And what you see on that chart is pretty much what's out in the universe. It's composed of these elements, and they combine different ways, and gases, liquids, and solids. We call that the 3 states of matter. And that's so important with the H2O cycle. Today's a day where there's a lot of H2O, but it's not in a cloud. It's in a cloud gas state, but you feel it because it's a lot different from a very dry day. And that's one reason that you feel hotter in this when there's a lot of H2O in a gas state, because the heat from your body cannot escape into the atmosphere. That's blocked by the H2O. So that makes it feel hotter than it is, because your heat doesn't really escape as well. So this humid weather makes it feel hotter than the actual temperature, because it's a wet heat. Your body cannot get rid of the heat because it's blocked by the H2O compound. And that prevents drying, the heat escaping. But that's just an example of cosmology. Everything we do or say or depend on or talk about is actually part of the deal of being a part of something rather than apart from something. So everything, Everything is dependent on the sun and this planet, the presence of H2O and the three states of matter. Another thing is that in this area there's only 6 months growing season here, but when it's on, like now, everything grows wild because there's so much H2O combined with the star up there. So you've got the star giving the light for the photosynthesis reaction, and then the plants either draw H2O from the roots or they can absorb it underneath the leaf. There's a stomate opening. So right now, other than the evergreens, which are not native to this area, all these trees and plants and weeds, everything is drawing in all this H2O with the sun's as a catalyst to put that chemical reaction into our life. So everything depends on that photosynthetic reaction as the beginning of the food chain. And then we work up to who we are. But the reason I mention that is because cosmology that's part of cosmology. You have to look at the entire picture. It's not just it depends on observation and measurements, but it's all there. It's all going on. So it's pretty wild, but as you'll see, like I say, everything that's on these sheets are here and now. It's just a matter of them photographing it. But even at that, it still took all the stars you see on these sheets a long time for the light to get here because they're so far away. You know, the one light source we have here is only 11 minutes away. It's light. Remember, the next closest star on all those sheets is over 4 light years, 4 years to get here. So that's how tied we are to this star. It's like you can't dismiss its effect on everything here. And as I said earlier, the time frame is mind-boggling, like billions of years this has been going on here. You think that something would veer off, like the Earth would fly off there and the sun would go somewhere else. No, they stay in this relationship for billions of years because it's governed mostly by gravity, and even stars have lifespans. And finally, every star gives out, it explodes, a nova or something like that. And that gives new material for other stars to form from what's blown off in death. And even if you look at a forest, when an old tree dies, it crumbles to the ground and forms soil, and then new life lives off what died of or something. So it's all chemistry, physics, but it's more than that, as we'll see when I finish up. I find it very challenging and very wild, extremely interesting. But this is one function of education, is to make people aware of what's out there, but also for them to participate in what's going on. So we live our lives like we got to do these things. We have to have the water brought in somehow. We have to use the light for growing. If it was dark 24 hours, I don't think we'd be happy. So right now it's light out, and what we experience right now is going to happen exactly half the time on this planet. It's only like this half the time, because when we get after September, it's going to be less of this than there is darkness. There will be more darkness than light after that date. But like I say, Christmas is that's the shortest we get, like maybe 9-10 hours of daylight out of 24 here. Whereas in June, it's the opposite. It's only dark about 7 or 8 hours. Now we're kind of in a transition, we're losing time. And that's all because of that axis is actually tilted 23.5 degrees. And because of that, from my 8th floor window, I could plot 47-degree sunrise on June 21st. It's going to go down 47 degrees to where it comes up in December. I could actually watch that on the eastern horizon if it's clear enough. The sun marches 47 degrees across the sky. So in December, it's shining over the fattest part of the earth, and that fatness there prevents it from coming up. So when it comes up in June, it's coming up over the polar area more, which is smaller circumference there. So that's what makes the difference in daylight on a yearly basis. But the reason for all this stuff is that we can't dismiss our actual experience on the planet from what's going on around us. That's what cosmology is trying to address, is the actual reasoning. We're people, we want to know why this is going on or something. There's a lot of astronomers and physicists out there. And, so anyway, when we're finished with that section, we'll start drawing the final conclusions, and it's pretty wild. It's anyway. So these pictures we're actually in the middle of what these pictures depict, this section. The first was, I said earlier, what's out there we're not involved with. It's out there, but it's actually, we're involved in these pictures right now, so. As one of the definitions I read about a galaxy is a large-scale group of stars, gas, and dust. All three of those things are there. And again, they estimate that there's 100 billion solar masses in the universe. Again, the smallest galaxy, 1,500 light years across, the largest, 300,000. And we're what they call a spiral galaxy. Remember the spinning around the pinwheel? That's what we're involved in here. In the southern hemisphere, you can see one of the cluster galaxies called the Large Magellanic Cloud. It looks just like a bunch of stars, but they're not organized like a spiral pinwheel. So anyway. We get done with that, I'll go to the final part. I think one thing to consider is why even address this issue? Why are we even here, or why am I here? But I think it's because we want to know. We have a mind that's activated by everything going on in the universe. We want to know, as people, we want to know what's happening. That's a gift we've been given. Various life forms, there's graduated levels of what's capable of them. So I find it fascinating. One way to experience a lot of this is to go to a planetarium. There used to be one in the Board of Education building on 6th and Walnut. I'm not sure if it's still there as a planetarium, but a planetarium is kind of physically tries to replicate everything we're talking about, particularly within the solar system. They have rising settings, and so the solar system, because of the sun, one thing that's key, if the sun was a basketball, just picture a basketball, the largest planet was Jupiter, would only be a table tennis ball. So you have a basketball versus a table tennis ball. That's the biggest planet. Saturn's almost the same size. The Earth is where we're sitting is be a pea. Compared to the sun's mass, the Earth would only be a pea in size. And it's going around this big object called a star. But as big as this planet seems to be, the sun or this local star is a basketball compared to a pea. That's something most people don't realize, that how huge this thing up there is. Massive. And it's a gas that's so hot and undergoing nuclear fusion that gives out the light and heat we're used to experiencing. But it's so big, it's, like I say, it's a basketball versus a pea. We're the pea. As big as this planet is, so it seems, we're only a pea compared to a basketball. So that's why the gravity of the sun is so vital. It keeps everything in exact same spot as it goes around. All the other planets are doing the same thing. They know how long it takes for each planet to go around the sun, which is the year. And they each know how many hours it takes for each planet to do a day. So in other words, go around and face the sun or not face the sun. So you can see the difference between day and night. Look at the difference. Last night it was without artificial lighting. You couldn't see your hand in front of your face if we didn't have lighting. That's how dark. Whether you're facing the sun or not facing, look at the difference that it makes. You know, everybody kind of knows that, but day is day and night is night. And again, each part of this planet is going to get the exact same minutes of facing this body, or daytime. But the angle's the difference. That's what makes the temperatures different in these locations. Okay, has everyone viewed the material? Okay, the wrapping all this up is that from being that we describe ourselves as a church according to the banner in front there, what does this mean of spirituality, of other things like why is this important? How do we relate to each other as people if we're in the universe as part of it, rather than apart from it? It means that everything has to interrelate with each other. And human beings and all the other life forms are doing just that. So that's where I think, for me personally, this is not meant to be any kind of final word on what we're talking about. I really feel that everything we've talked about and observed and experienced is a result of a cosmic love. I don't think that everything going on out there would happen if love wasn't present. And I think that's, for me, that's the driving force of it has to be there before it can be subjugated internally, and most importantly, before it can be objectified to other sources. You have to experience the love of this exact physical, immutable thing called the universe to know that the only reason it could be so dependent psychologically or emotionally is that it's love-driven. And I don't think anything in the universe would be the way it is if the overall love force wasn't there. That leads to other people's opinions and churches, whatever, churches get involved in this, but I think that for me, love it's free, it doesn't depend on paying, it's not depending on what other people think or say or do, it's just a force that actually drives everything for me that we've talked about here today. And I think one of my most admired people, John Lennon, said, the love you take is equal to the love you make. And so we have to have something to start from. And various religious leaders and all these denominations, they all have people that have been luminaries in each one of these groups that, they all kind of look for the same thing. The difference is opinions and things get in the way sometimes, but I think that the whole universe is only dependent on and is as present as what it is because the love force behind it. And it's free, it's a gift, we don't have to buy nothing, just observe every day what's, the daylight, the change in temperature, how long the sun is out or whatever. Growing seasons, like here's exactly 6 months. Everything goes dormant around here except for the evergreens after November 1st and stays that way until May 1st. Everything sleeps, leaves fall off, and that's it. And all we have is look forward to May 1st again. This whole cycle starts up in this area. Yeah, one more last thing. All the evergreens living around here are not native to here. They're farther north, maybe 100 to 200 miles, where they depend on different things to stay alive. Anyway, that's a diversion, but the key thing is that I've just changed the wording around. One of the religious leaders most of us have been familiar with in our culture is that love the universe with all your heart, soul, mind, and strength. And love your neighbor as yourself. That was one person's opinion, but I think it works. It's the only thing that you can actually count on. Everything will take care of itself. Thank you for coming, and it's real nice to be here. Thanks. So let's have our closing prayer. As we extinguish the chalice, we extinguish this chalice, but not the light of truth, the warmth of community, or the fire of commitment. These we carry in our hearts until we are together again. Okay.